All right, let's run through another Mtel question. This one says, a boat starts from a dock located at the point 0, 0 and travels in the direction of the point 3, 4 at 25 miles per hour for 2 hours. Then the boat heads straight towards an island located at the point 50, 48. If each unit represents 1 mile, which of the following vectors represents the direction of the boat when it heads towards the island? All right, let's draw a coordinate plane first. All right, so there are axes that represent our coordinate plane. We're told that we're starting at 0, 0, so we're starting at the origin and traveling in the direction of some point in the direction of 3, 4. So basically what that means is every time we move over 3 on the coordinate plane, we're going to go up 4, and we're going to do that for 25 miles per hour for 2 hours. So in 2 hours at 25 miles per hour, we'll travel 50 miles. Right? 25 miles per hour, and we're doing that for 2 hours. So 25 times 2 is 50 miles. So if I draw our vector starting at the origin, it should have a slope of over 3 up 4 and be 50 long. So I want to know what this point is right here, where we're located on the coordinate grid. If I go over 3 up 4, we're going to create this little similar triangle at this spot. And if I consider a triangle with one side of 3 and another side of 4, and then I can find the hypotenuse, I'll be able to create similar triangles and figure out what this point is. So this is a pretty classic right triangle where we have two sides that are 3 and 4. I know that this side is going to be 5 just from doing a lot of math, but we could use the Pythagorean theorem to prove that. We know that a squared plus b squared equals c squared. So if we do 3 squared plus 4 squared, that's going to equal our c squared. Let's pretend we don't know that this equals 5 yet. So 3 squared is 9, plus 4 squared is 16. It's going to equal our c squared. 9 plus 16 is 25. That equals c squared. Solve this. We're just going to square root each side. Square root of 25 is 5. So that is our c, which is going to be the hypotenuse of our triangle right here. We know that this is a similar triangle because this vector was traveling at over 3 up 4. So we can use the concept of similar triangles to find the x and y value of this point, which are the sides of our triangle. So 50 is 5 times 10. So this triangle is 10 times as big as this small triangle that we just created. So this would have to be 40, and this would have to be 30 in this triangle. So this point right here is 30, 40. And then we know we're going to some point 50, 48, which I can label on the graph right here maybe. And we're wondering about the direction of this vector right here. So the line between these 2 points. Well, since I know this point is 50, 48, I can just subtract the x's and subtract the y's to find the direction of the vector. So the direction of our vector would be the x's subtracted, so 50 minus 30. And the y's would be 48 minus 40. So we get 20 in the x direction and 8 in the y direction. And we can simplify this ratio by dividing both numbers by a common factor. 4 goes into both of these numbers. If we divide both of these numbers by 4, we're going to get 5, 2. So that is the direction of that particular vector.